Hey everyone, today we're going to look at a few other ways to multiply polynomials, namely special products are what we're looking at today. So what we've talked about before is just different methods to multiply binomials. So we've talked about using our box method. We've talked about this idea of FOIL, right? Where FOIL, of course, stood for, you multiply the first things in each term together, and then the outside, okay, then the inner, and then the last things together. So those will still work, and of course, it's going to work for every polynomial that you come across. So the idea of FOIL is going to work for everything, but sometimes there's an easier way to do things. And for example, if we look at things just even like simple multiplication, well, if I ask you to find what is 11 times 5, most of you are not going to write this down and then take, all right, 5 times 1 is 5, so on and so forth. You're able to do that in your head. And you know what the algorithm's like. You know how to multiply those together. And we're able to do it much more quickly. So that's what we're looking at doing today, is some of these special product patterns. So the idea is that, all right, if I'm going to multiply things together where the numbers in the front are the same and the numbers in the back are the same, but the signs in the middle are different, meaning one's addition, one's subtraction, it is always going to multiply or distribute out to this. Okay. Similarly here, if they're exactly the same, all right, both of them, they're going to be in these formats here. And if you notice, the only thing that's different about these, well, starting over here, right, here I have addition, and here I have subtraction for both of them. The only thing that's different in the formulas is that if everything's positive, this is a plus. If everything is negative here, so minus and minus, then your middle term is going to be negative. So if you write down one thing today, please make sure it's the stuff on this slide. All right, let's look at a couple examples. All right, so here we have these are opposite each other, so x minus 2x plus 2. So the idea here is that, all right, I can do just the first term squared, and then it's minus the second thing squared. So 2 times 2 is 4, and that's going to be my answer. Again, how does this work? Well, if I were to FOIL this out, x plus 2, x minus 2, all right, I would get x squared plus 2x minus 2x, and then minus 4. Well, what happens? These are opposite, so they are going to cancel. And we just have x squared minus 4. And that's going to be true regardless of what you're multiplying. So if they're opposites, it's always just the first squared minus the second squared. So similarly here, right, I have a 2x in front in both of these, and a 1 in the back of both. Well, the signs are different, so it fits my format. So I'm going to do 2x as the first term, so it's 2x squared, and then minus my second term squared. All right, notice I have this in parentheses because all of that stuff is the first term. So I have to take 2x times 2x, which is 4x squared, and then, of course, 1 squared is 1. All right, looking at this one now, okay, so we have things that are exactly the same. So this is exactly the same as this. So what our formula was it's our first term squared, and then it's always going to be 2 times the product of both the first and the second, and then plus the last thing squared. And then simplifying, I get x squared plus 8x plus 16. So again, is this the same as FOIL? Absolutely. If I FOIL this, it would be x squared plus 4x plus another 4x plus 16. Notice this is the same as this, which means there's 2 of them. So that's where the formula comes from. So the formulas, if you recognize them, it is going to speed things up, make things go a little bit quicker. But if you're not sure if they work or not, our regular methods still apply. All right. So let's try this one here. Again, the first is exactly the same as the second, which means it is going to be, excuse me, I'm getting ahead of myself. So the first term squared, right? Now they're minus here, right? So it's minus, and then we said it was 2 times each of the terms, so I have a 3 and a 2x. And then lastly, all right, it was going to be plus this number squared, simplifying 4x squared minus 12x plus 9. One last one we want to look at. Now, common mistake here. A common mistake we see is, well, we just want to square this, so I get x squared plus 7 squared, which is 49, and this is not okay. All right? This was very similar to one of our properties we talked about with exponents, which looked like this, where that said we could distribute our exponent, for lack of a better word, but here this was multiplication. Here we have addition. Those are completely different. So what we need to look at is, what does this mean when this whole thing is squared? Well, this means it is x plus 7 times x plus 7. All right, so this fits our special product, or I would have x squared plus 14x plus 49.